In this video, we're going to go through a 2.3.1 problem in which we compare the rates of change of different functions. So I'm given a graph and an equation, and I'm asked to identify the function that is increasing faster. So the first thing I notice is that it's asking me which is increasing faster, and I like to make a little note to myself what that means in terms of the distance from zero. When we're comparing slopes, remember we don't care about positive and negative, we care about their distance from zero. So if I'm looking at what's increasing faster, I'm looking at what's furthest from zero. So then I want to look at my two functions. My first one, my graph, I really just want to count rise over run. So here's a point right in the middle. And then there's another point, I think, right here. And so I'm going to count the rise over the run of this function. And if I look at that from here to here, I'm going to go up 1, so rise positive 1, over running 1, 2, 3, 4. So my slope is 1 over 4. Then for my equation, well, I just need to figure out what the m is. And so the m in this situation is 1 over 4. So my slope over here is 1/4 as well. So now I want to go answer this question. It says, which is increasing faster? Well, if they're the exact same, they're the same distance from zero. So I'm going to put they are increasing at the same rate. And it says to explain, so I'm going to add the word because. And I'm going to say their slopes are the same, meaning they're the same distance from zero. So if it was asking us which is the steepest, that would be the same question as well. And the other type of problem is one that involves a table. The only addition to that is instead of it being as easy as just pulling the m out of it, we would want to pull out 2 points in x comma y from the table and use our slope formula. If you need a reminder of slope formula, remember it's m equals y2 minus y1, and that's over x2 minus x1. So that's helpful when you have either 2 points or a table.